Hi, welcome to Real-Time Visualization with Unreal Engine 4. I'm Tom Shannon, a technical artist here at Epic Games, and we're going to talk today a little bit about how people are using Unreal Engine 4 for architectural engineering and automotive and other types of visualization. We're currently in the middle of a mass migration to real-time rendering in the visualization field. Previously, the visualization field has been dominated by offline renderers like V-Ray or Mental Ray. And in the last few years, we've seen a huge uptick in the use of real-time technologies in, of course, games, which have always used real-time technologies. Film and television have embraced real-time tech. Research and training are using augmented reality and virtual reality along with real-time technology. And of course, AEC visualization has become a huge, huge industry embracing real-time technology to produce stunning visualizations in a fraction of the time that they used to require. In fact, here's just a quick look at some of the companies out there that are using Unreal Engine and real-time technologies for visualization. So why real-time? Why are these companies ditching V-Ray and these tried and true software renderers for this real-time kind of workflow? Well, it really just boils down to these four things. The rendering is fast, and I'm not just talking slightly faster, I'm talking tens of thousands of times faster. If you compare a single frame that takes 20 minutes to render using software rendering to a single frame that takes a 30th of a second to render in Unreal Engine, you're looking at 36,000 times faster in Unreal Engine. That is a huge delta, and it's something that you just can't ignore. Along with that comes fast iteration. You're not waiting for renders. Renders happen in a fraction of a second, so you can make changes and make decisions on the fly. And of course, that is what we call interactivity. When you can see what you're working on and change it in real time, you can interact with it. And then when you add in the power of blueprints in C++, you can create interactive experiences as well. And then lastly, there are new workflows that are being developed right now. So film and television are completely redoing their entire production pipelines to move to a virtual production pipeline. And it's turning the entire production pipeline on its head. And it's really amazing. These workflows are emerging. They're brand new, and they're getting developed on a day-to-day basis. And it's really exciting to watch these new techniques and these new workflows that studios are coming up with. And so why now? Real-time's been around for a long time. Video games have been around for decades, and they've used real-time technology. Why is it now that visualization has decided to embrace real-time? Well, obviously the first thing is visual fidelity. Things now in real-time look as good as they used to look in offline renderers. So the visual fidelity has finally hit the quality bar that people have been looking for. Second is cost. Previously, high-end real-time engines like Unreal Engine were very, very costly. We're talking hundreds of thousands of dollars up front, possibly more in the long run. Now, Unreal Engine is free. And many of the tools that you use to develop for Unreal Engine have come down in cost significantly. So now you can afford to fit your entire studio with the hardware and the software that you need at a reasonable cost. And of course, that's the hardware too. Hardware has become so much faster. The video cards of today are amazingly fast and are relatively inexpensive. All of this combines to kind of the perfect storm. So now we have great quality, need, and everything's coming together, and the future is now. So studios are adopting real-time because they have to. They have to keep up. So why are they choosing Unreal Engine 4 for their real-time solution? Well, the first reason is obvious. Visual fidelity again. Unreal Engine 4 looks amazing. The renderer is a world-class renderer that produces amazing images. Did I mention they look amazing? The physically based rendering and lighting system, the material systems, along with workflows and techniques that people are developing as they're working with Unreal Engine, are leading to just some amazing visuals, really high-end quality that rival and sometimes exceed the level of quality from offline renderers. So the next reason that people are choosing Unreal Engine 4 is because of its flexibility. Because Unreal Engine 4 gives you full source code, C++ access, you can do whatever you want with Unreal Engine 4. If you need to integrate a special piece of hardware, no problem. Special piece of software, you've got access right there. You can modify the Unreal Engine down to its core. Or you can use something as simple as blueprints to develop interactive applications. So you can make something incredibly advanced or something very simple. Unreal Engine is extremely flexible and it's suitable for the biggest projects or the smallest projects. And of course, it's fun to use. Unreal Engine 4 was developed by a game company for other game companies to develop video games with. So fun is in its DNA. Unreal Engine is a complete set of professional tools that are free to use. You don't need to get anything additional to get started. You just download Unreal Engine and you're ready to go. So those features are just too numerous to mention. Unreal Engine 4, like I said, is a huge, full tool set. You've got a full PBR lighting pipeline and material system, foliage for populating your scenes with thousands of trees, flowers, grass, sequencer, which is an amazing linear animation editor. We've got visual effects. We have ways to profile, cloth simulation, you name it. If you need it to produce a AAA high-end video game, it's included. Plus, we've also started to look at the visualization field and our non-gaming customers, and we're starting to put in a lot more of that technology into the engine as well. So the key features for visualization out of that huge list, it's hard to choose, but if I had to choose, and I did have to choose, I'd choose these four. So the first is the PBR, or physically based renderer. Physically based rendering is a way of defining surfaces in light in a more physically accurate way. And the benefit of it is that materials are very easy to author using PBR. The graphs that you have to produce are very simple compared to old video game and real-time materials, and even compared to some of the offline materials that you're used to using. The other big benefit of physically based rendering is that materials and lighting look correct in every material and lighting scenario. As you can see here, these same 6 materials are put into 4 very different lighting scenarios, and in each one, they still read as a correct material. Next up would be sequencer. Sequencer is our linear animation tool. It's kind of like After Effects, Premiere, Visual Effects Studio like Nuke, and then your renderer and your DCC app all combined into one. This is incredibly powerful. Now you can edit camera animations, animations in the scene, everything right in the engine, and render out directly from there, or use these sequences in interactive applications. It's really, really one of my favorite tools in the engine. But my favorite tool is Blueprints. Blueprints is what is allowing individuals and studios to experiment with interactivity in real time without having to write a single line of code. It's a visual scripting language that's tied deep into the editor And it gives you access to probably 90% of the functionality of Unreal Engine without having to code. And it lives within the engine. It's incredibly fast, easy to learn, easy to use. And it lets people with very little programming or no programming experience build amazing applications. So last up on this list is Unreal Studio. As I mentioned before, we have been working internally to improve Unreal Engine for our non-gaming developers. And the first step in this is Unreal Studio. Unreal Studio is a collection of tools and workflows designed specifically for visualization and engineering so that you can get your data from your visualization scenes or your CAD applications directly into Unreal Engine very easily. We call it frictionless workflows. So here's an example of a scene that was built in V-Ray and 3D Studio Max on the left, and then brought in using Datasmith with Unreal Studio and rendered in Unreal Engine on the right. And you can see the quality is very good. And what's worth noting is that this was almost a direct import in without a whole lot of work done to improve the Unreal scene. It's pretty amazing. So Unreal Engine is great, and it's being adopted worldwide in pretty much any industry that renders an image. Unreal Engine is either being considered or adopted. So what are your challenges going to be doing that? Either learning Unreal Engine as a visualization artist or starting from scratch and learning visualization using Unreal. Well, the first one is probably the biggie, is that developing an Unreal Engine 4 is much more like software development than it is rendering or film. Even an Unreal Engine project is built more like a software development project with a collection of files and folders that come together to run an application. You have programming, you've got new skills that your team might not have already. And so that's probably going to be the biggest shift that your team will have to make adopting Unreal Engine or any sort of real-time technology, is adopting a more software development-like workflow. Next up is optimization. To render scenes in under a second or even at a 30th of a second at 30 frames per second, you have to spend some time making your scenes very optimized. Unreal Engine is a very fast renderer, but you still have to do a little bit of work to make sure it's rendering as fast as possible. So optimization is key. Optimizing your assets from the beginning, understanding how Unreal Engine renders and where your performance pitfalls might be are key to achieving your vision in Unreal Engine. Next is delivery. Most visualizations previously, non-real-time visualizations, are delivered maybe one of two or three ways, either as a JPEG image, as a still image, or as maybe a movie file or hosted on YouTube. With an interactive application in Unreal Engine 4, you can deploy to any of these platforms, from PC and Mac to mobile, VR, and each one of these platforms has its own considerations, its own benefits, and its own development environment. So if you are looking to develop for more platforms than just PC or Mac, there's going to be a learning curve there as well. And of course, one of the biggest issues is player agency. Like this cat, your players are going to go everywhere. They're going to look at every corner because they can. People love to explore. And when you give them the ability to explore an interactive environment, they will do exactly like this cat does. They're going to look at every corner and open every closet that they can find. They're going to see if light switches will switch. And, you know, previously you really had what you would call a viewer, someone who passively watched your visualization. They would see your image or watch your movie. In Unreal Engine, that viewer becomes a player, and they have agency, and they can move, and they can interact. And you have to be aware of that. The next really big challenge, and it ties into the software development workflow, is collaboration in Unreal Engine. With traditional visualization, you probably worked with monolithic files and smaller teams, and one person worked on the max file or the XREF file at a time. Whereas in Unreal Engine, you have hundreds of files that can all be edited simultaneously. And Unreal Engine scales to hundreds of people working on a single project at a time. But this is a workflow that's typically very foreign for visualization houses. Unreal Engine, however, does ship with support for GitHub, Subversion, Perforce, and now Shotgun. This lets you, if you're already using one of these workflows, you can integrate it directly into Unreal Engine 4, or you can start to look at these software management systems and decide which one works best for your team and your studio and start integrating it. So finally, we'll just recap here. Real-time technology is sweeping pretty much any industry that renders images, and especially in visualization. Real-time technology is so much faster and reduces the costs and risks of visualization that it's a no-brainer. And Unreal Engine has become kind of the premier tool for real-time rendering. Because of its quality, its flexibility, and Epic Games' dedication to visualization, film, and non-gaming industries, its adoption is just a snowball that just can't be stopped at this point. It will be a challenge to adopt a more software development-like workflow for most studios. Most studios don't have programmers and technical artists on staff, and adopting your workflow to be more software development-like will make the adoption of Unreal Engine much, much easier. And of course, finally, Unreal Engine is a complete tool set. Everything you need is there, from sequencer to material editing, post-processing. Everything ships with the engine. You get it for free. So thank you for tuning in. I hope that this was helpful in your journey, and I'll talk to you soon.